How confident are you in answering test questions about projectile motion? In today's video, that's exactly what I'm going to discuss with you. I've selected 4 conceptual questions and 1 problem solving regarding this two-dimensional motion known as projectile motion. Before we start answering the questions, let's first have a look at the summary of projectile motion, the key concepts, right? So, in particular, we have to describe the acceleration, the net force acting on the projectile, its velocity, as well as its displacement. So for the vertical motion, these are the concepts, all right? We say that the type of motion involved is uniformly accelerated, while for the horizontal component, it is characterized by uniform motion, right? And for acceleration, we say that the vertical acceleration is always constant, and that is equal to negative 9.8 meter per second squared, while the horizontal component of the acceleration, ax, is equal to 0. This is because the net force acting on the projectile, A, along the vertical, the net force is just the force of gravity, and that is always directed downward. Hence, for the acceleration, it is also constant at negative 9.8 meters per second squared, but for the horizontal component, there is no net force, and therefore, the acceleration is also equal to 0. Now, for the velocity, when the body is moving upward, we say that the magnitude of the velocity is decreasing, right? It is decreasing but going to the positive direction, all right? When it reaches the highest point, we say that the vertical component of its velocity is equal to 0, and on its way down, of course, it's the magnitude of its velocity is increasing, but since it's downward, therefore it is negative. While for the horizontal component, we say that the uh, horizontal component, Vx, that's how we label it, is always constant anywhere in the curved path. And lastly, for the displacement, all right, supposing you are trying to determine the vertical component labeled as delta y in terms of the time t and the given initial component of the velocity v sub naught y. So the formula is simply delta y is equal to v sub naught y multiplied by the time plus 1 half gt squared. And another possible formula that you can use is that of the maximum vertical displacement, or Hmax, which is equal to the square of the initial or actual initial velocity v naught multiplied by the square of the sine of the angle theta, where theta is the angle that the projectile makes above the horizontal, okay, divided by twice the acceleration due to gravity. And for the horizontal component, okay, the change in the horizontal displacement delta x is simply the product of the horizontal component of velocity v naught x multiplied by the time t. But if you are looking for the maximum horizontal displacement, Rmax, again, we have the initial velocity v naught squared multiplied by sine of 2 theta, all right, divided by g. So these are the important key concepts in analyzing the motion of a projectile. Question number 1. A baseball is hit upward and travels along a parabolic arc before it strikes the ground. Which one of the following statements is necessarily true? Ignore air resistance. Letter A. The acceleration of the ball decreases as the ball moves upward. Letter B. The velocity of the ball is zero when the ball is at the highest point in the arc. Letter C. The acceleration of the ball is zero when the ball is at the highest point in the arc. And letter D. The x component of the velocity of the ball is the same throughout the ball's flight. Alright, so the correct answer here is, of course, it is letter D. So, why are options A, B, C considered incorrect? For letter A, the acceleration of the ball decreases. That's what makes the statement false. Because we said earlier, or as everybody knows, the acceleration of the ball or of any projectile is always constant, equal to negative 9.8 meters per second squared, whether it's moving up at the highest point or moving down. Letter B is also incorrect because the velocity of the ball, when it reaches the highest point in its trajectory, is not equal to zero. It's only the vertical component, the velocity, that is instantaneously equal to zero. But since the horizontal component is always constant, therefore we say that the actual or resultant velocity is not zero. For letter C, the acceleration of the ball is zero when the ball is at the highest point of the arc. That's related to letter A. We just said earlier that the acceleration of the ball at any point in its trajectory is always constant, okay, including at the point or at the highest point in the arc. The acceleration is still negative 9.8 meters per second squared, so that only makes letter D as the best answer. Alright, the x component velocity of the ball is the same throughout the ball's flight. Question number 2. 4 marbles are projected or released simultaneously from the same point or elevation. Okay, you have here the diagram. Marble A is released horizontally. Marble B at an angle theta equals 45 degrees above the horizontal. So there's marble B. Marble C also released at the same angle theta but below the horizontal. Okay, below the horizontal. So this is also 45 degrees. That's 45 degrees there. And marble D is simply dropped straight down. Okay. And we say further that marbles A, B, and C all have the same initial speed. Okay. And marble D has zero initial speed. So among the 4 marbles, it's only marble D that has zero initial speed. Alright? It is simply dropped downwards. Okay? It is not what you call projected horizontally. Okay? It has no horizontal component. It's like an ordinary free falling body. Okay? That is marble D. Alright? So, how do we analyze this? The question is still in the next slide, but at this point, because we still have here the drawing, all right? When you say the same what's that? The same initial speed, all right? The same initial speed, all of them have the same initial speed. For example, if the initial speed of A is, say for example, 10 meters per second, okay? That is also the speed for marble B, 10 meters per second. Similarly for marble C, that's also 10 meters per second. All right. The only difference is that their direction, initial directions are different, right? So the key word used here is the word speed, the same initial speed. We cannot say that they have the same initial velocity, all right? That's different. The fact that all these marbles, marbles A, B, and C, all right, are projected at different angles, all right, from the horizontal, even if the magnitude of their velocities are the same, but velocities per se, okay, of these three marbles are not the same. The best term to use is initial speed. All right, let's now look at the question. So the question for question number 2, which marble or marbles will have the greatest speed just before hitting the floor? Again, we have to ignore a resistance, and we are looking for one or more answers. So again, the choices are letter A, marble A, letter B, marble B, letter C, marble C, and letter D, marble D. All right. So it was earlier mentioned that um, among the four marbles, it is marble D that has no horizontal component of its motion. Okay, and that the speed of marbles A, B, and C are all equal initially. All right. So uh, the angle above the horizontal, the angle of projection for marble B is 45 degrees, and so as the angle of projection for marble C is also 45 degrees, but below the horizontal. All right, now, uh, in answering this question, we have to first establish that uh, the velocity or the speed, all right, the speed of marble B, okay, initially, the speed of marble B is equal to the speed of marble C, in fact, also equal to the speed of marble A, all right. But upon reaching this level, remember, marble B is still going to go up and then comes back. When it reaches that level, level 1, in our diagram, level 1, uh, the speed of marble B will still be equal to the speed of marble C, all right, when marble C is still at that level. So that is the meaning of this equation, which means that when they reach the floor, okay, the level of the floor is now labeled as level 2. So upon reaching that, or just before reaching the floor, we also note that the speed of marble B and that speed of marble C are also equal. All right. Now, as far as marble D and A are concerned, we say that the vertical initial component of the velocity of marble D, all right, is 0, and that goes through also for marble A. They both have 0 component along the Y initially, all right. So when they reach the floor or just about to hit the floor, marbles A and D will also have the same y component of their final velocity. That is the meaning of the first equation. Uh, v dy2 is equal to bay2. All right. But each of this velocity or speed along the y, okay, in fact, is less than the y component of the final velocity of marble B and marble C. All right. Which means that our answer to this question would be uh, both marbles B, all right, and marble C will have the same what we call uh, speed just before hitting the floor. So a follow-up question, which marble or marbles will have the greatest horizontal distance just before hitting the floor? Horizontal distance here refers to the range, okay? The range of the marble in moving from the top of this elevation before hitting the floor. And since it was already mentioned that marble D, among the four marbles, marble D has no horizontal component of its motion. That means we are only left with marbles A, B, and C, okay, as possible answer to this question. And to do that, to be able to determine which marble has the greatest horizontal distance, we need the equation that relates the range or delta x, all right, to two factors, the x component of the velocity initial and the time of flight. Now, since marble B and marble C, okay, exactly when marble B reaches this level 1, okay, remember marble B still has to go up, okay, reaches the maximum height, then it comes back to the same level or level 1. At that instant, marble B's speed is just equal to that of marble C when marble C was just starting to move. All right, so the fact that marble B still goes up, then comes down, it means that it takes longer time for marble B to travel. All right, that distance, horizontal as well as vertical distances. All right, so it follows that among the three marbles A, B, and C, it is marble B which will have the greatest horizontal distance or range. Of course, followed by marble A, because marble A's initial velocity or initial speed is purely horizontal or Vx, whereas for marble C, uh, it's what we call horizontal component is much less than that of marble A. The fact that marble C also has an initial y component, okay, that makes its x component much less than the x component of the velocity of marble A. So in short, we can now compare um, the horizontal distances of the three marbles A, B, and C, all right, and we say that among the four marbles, it is marble B which will have the greatest range, of course, followed by marble A, and then the third is just marble C, and the last is marble D. The fact that marble D, okay, has no horizontal component of its motion. In short, our answer for this question is letter B. All right, this is our last conceptual question. Okay, which statement below is necessarily true or correct when the equation R max equals bi squared sine 2 theta over g is applied? Okay, so this was already presented earlier. The R max is the horizontal distance acquired by a projectile, all right, when the projectile is launched at a certain angle above the x-axis or above the horizontal labeled theta. Okay, v initial is the actual initial velocity, then you square it. We're not talking about the x component, the velocity, but this is the actual, okay, the actual uh, velocity that makes an angle theta above the horizontal. So in using this Armac's formula, okay, which among the statements A, B, C, D is necessarily true. All right. So we note here that the angle theta is from the positive x-axis. In short, we're talking about a kind of projectile that is launched diagonally upward. All right. This doesn't apply. This formula doesn't apply to cases when a projectile is just launched horizontally, all right, or diagonally but downward. If the angle is below the x-axis, okay, that's not uh, that's not a situation where we can apply this formula. So looking at each of the options, letter A, two projectiles launched at angles 30 degrees and 60 degrees will have the same range. Letter B, two projectiles with equal initial velocity, all right, launched at angles 15 degrees and 75 degrees will have the same range. Then letter C, two projectiles with equal initial speed launched at angles 25 degrees and 65 degrees will have the same range. And option D, as the angle of launch of a projectile increases from 0 degree to 90 degrees, the range also increases. All right, so these statements have something to do with how you understand the meaning of this equation, Rmax. All right, so earlier, while discussing the concepts, I already mentioned to you that the meaning of sine 2 theta, all right, is that before you get the sine value of the angle theta, you first have to multiply the angle by 2, right? That is what we mean by sine 2 theta. Then divide it by g. All right. So assuming that the value of v1 is the same, constant, and the only thing that differs between two projectiles is the angle of launch. All right. The angle of launch, for example, 30 degrees. Okay. Case 1 is the angle of release or the angle of projection is 30 degrees. And for another projectile with the same initial speed, the angle of projection, for example, is 60. All right. The first projectile has an angle of projection of 30. The second one has an angle of 60. So what happens? You can check. All right. Since we let vi equals a constant, so we just look at what's going to happen to the r or to the horizontal displacement, no? If those angles are considered. What is the sign of, for example, if the angle theta is 30, that means that's 60. All right. What is the sine value of 60 degrees? All right. You can check that in your calculator. And what if the angle is, or the theta is doubled? Make it 60 degrees. Since we multiply by 2, that becomes 120. All right. And what's the sine value of 120 degrees? You will find out, you check with your calculator, that the sine values of 120 and the sine value of 60 degrees are just equal or the same. In short, I'm sure you know this already, that if the two angles of a projection are what we call complementary angle. Complementary meaning if you add the two angles, their sum must be equal to 90 degrees. All right? So 30, the complementary angle of 30 degrees is of course 60 degrees. All right? That's in letter A. The two angles mentioned are 30 degrees and 60 degrees. All right? So it says two projectiles launched at angles 30 and 60 will have the same range. All right? That's the way it is stated. No mention about the initial speed. It just mentioned the angles 30 and 60. All right. You know what the best answer is? All right. The best answer here is actually option letter C. All right. Now you start to wonder why. Okay. You will notice that statement B and statement C are just quite similar. All right. What's the difference? It is the choice of the word. Okay. Here we talk about, in letter B, we talk about initial velocity, while in letter C, we talk about initial speed. So what's the difference? Why is letter C a better answer compared to letter B? All right. When we say the two projectiles are of the same initial velocity, okay, it should mean that the magnitude of the velocity of the two projectiles must be the same. All right. And their directions must also be the same. But how can that be possible when it states that the angles are different? All right. So there is something contradicting here. Okay. The use of the word velocity makes the statement questionable. All right. We cannot have the same initial velocity while having different angles of projection. Okay. Whereas in letter C, the use of the word initial speed, we're only referring to the magnitude of the initial velocity. All right. So it's a better answer because we are safe. If you use the word initial speed, their directions may be different. And in fact, the first one, all right, the first projectile has an angle of 25 degrees, all right, from the horizontal, and the other one, 65 degrees. But their initial speed, okay, are the same. It's just that the angle of projections are different. And 25 as well as 65 are complementary angles. So when substituted in the formula, okay, the sine value, for example, of twice the theta 25, that means 50. The sine of 50 degrees is just equal to the sine of 130 degrees. 65 times 2 is 130, all right? So having the same speed, that means their Rmax will be the same. So in short, letter C, okay, is necessarily true or correct, but not letter A. Two projectiles launched at angles 30 degrees and 60 degrees will have the same range. What is lacking here is to specify that their speeds, all right, must be the same. It doesn't say here that the speeds, all right, for these two projectiles are equal. So in short, this is not necessarily true, all right? They may be complementary. The 30 and the 60-degree angles are complementary, but no mention whatsoever about their initial speed. So it's not necessarily correct, all right? So we already explained why letter B is also incorrect. And wait. Letter D, option letter D says, as the angle of launch of a projectile increases from 0 to 90 degrees, the range also increases. That's not really accurate because, again, using this formula, all right, what do you think is the maximum angle? At what maximum angle will a projectile acquire the maximum range or the greatest value of range? At what angle? It is at angle 45 degrees. All right? Where the sine value of twice the angle, which is 90 degrees, is already the maximum possible value for the sine, which is equal to 1. All right? But starting from 0 angle or 0 degree angle, okay, from 0 degree to 45 degrees, but not 45, okay? Not inclusive, but exclusive, okay? The range should be increasing, all right? And then, beyond 45 degrees, all right, up to 90, okay, 90 not included, again, it's exclusive. What happens to the range? The range in fact decreases. As the angle approaches 90 degrees, there will be no more range, isn't it? So that statement in option D is not exactly true. All right. If you are asked to modify this statement, what you should say must be, as the angle of launch of a projectile increases from 0 to 45, then the range increases. But if the angle is increased from 45 up to 90, the range decreases. That is how you should modify this statement. But right now, it is not necessarily true. So the best answer, therefore, is letter C. All right. We are now on the last question, which is not a multiple choice question, but it's an open-ended problem-solving question. So we have a rifle, all right? A bullet is fired at an angle of 30 degrees below the horizontal with an initial velocity of 800 meters per second from the top of a cliff. All right. So here's our what do you call this, sketch of that situation. Supposing this the top of the cliff, and uh, a gun or rifle is aimed, okay, in this direction, okay, making an angle of 30 degrees below the horizontal or the top of the what do you call this, that top of the cliff, okay. So from that what do you call this, dash line, right, from the dash line, the angle below it is what we mean by 30 degrees, right? And the magnitude of the initial velocity of the bullet is 800 meters per second. All right, so we are tasked to determine the height of the cliff, all right, labeled here as capital H. The distance or horizontal distance from the bottom of the cliff, all right, up to the point where the bullet hits the ground, okay, is given. The range is given as 141 meters, all right. So how do we answer this question? Notice that nothing is mentioned about the velocity upon hitting the ground. Okay, although we know the initial velocity, which is 800 meters per second, but there's no mention about the final velocity. All right. So what is the equation and what is the quantity that we have to first calculate? All right. So we will see. Um, the first thing that we're going to calculate is the x and the y components of the initial velocity. All right. This is how it is done. We get the x component by simply using the formula v1x equals cosine 30 degrees multiplied by the uh, initial velocity of 800 meters per second. Right? Why cosine? Because the x component for this initial velocity is the adjacent. All right. We can imagine a right triangle here. Okay, the right triangle is such that the given initial velocity, okay, constitute the hypotenuse. All right, and the x component of that velocity becomes the adjacent side of the triangle. All right, so therefore the trigonometric function that is suitable in finding the x component would be cosine. Cosine of the angle 30 degrees times 800 meters per second. Okay, using your calculator, we get that value of B1x, 693 meters per second. And how about the y component? All right, the y component um, is simply determined by using sine of the angle 30 degrees and multiplied by the same value of the initial speed. All right, because the y component is actually the opposite side. If you imagine again that uh, triangle, okay, it is the side opposite to the angle 30 degrees. So when we are getting the ratio of the opposite side to that of the hypotenuse, it must be sine. That's the meaning of sine of the angle 30 degrees. All right, so again, doing your using your calculator, all right, we will get the value for B1y, which is 400 meters per second. But we include the minus sign because this y component is directed downward. All right, so that negative sign of our uh, B1y must be emphasized because we are treating this uh, quantity as a vector quantity. Okay, so from there, how do we continue with our computation? Now that we know the y component of the initial velocity, okay, we can now determine the time of flight, okay, the time t. How long it will take for the bullet to hit the ground, okay? That is what we mean by the time of flight. And that can easily be determined because we are already given the horizontal displacement or the range, which is 141 meters. Okay, the relationship between the range and the Vx, all right, is such that, okay, we earlier represented this. The range is just equal to Vx multiplied by the time t. And transposing that equation to solve for the time t, we have range divided by Vx. All right, so we just divide 141 meters because that's the value of the range by the x component, all right, of the velocity, 693 meters per second. That's the one there, all right? And what we get is a value of the time of flight equals 0.203 second, okay? We, what do you call this? We follow that the rules of significant figures where our answer has to be in 3 significant digits. So that's the time of flight, okay? That will now help us determine the variable height, all right? Or the displacement, the downward displacement of the bullet, okay? Sometimes also referred to as the delta y. But we just have it directly in our equation to find the height h, all right? Although we will be treating it also as a vector, but our symbol is already the symbol for the height h. All right, but we will be treating the downward velocity b1y as a vector quantity as well as the acceleration due to gravity, which is negative 9.8 meter per second squared. We already know the time t, so upon what you call this, upon substitution, okay, the b1y or the downward vertical component of the velocity has been determined earlier. That is negative 400 meters per second. All right. So I will not include the unit here anymore for lack of space. All right. So negative 400, that will be multiplied by the time of 0.203 seconds, and then add half of the value of g, negative 9.8. and then the square of the time, 0.203 square. All right. What we will get when we multiply negative 400 times 0.203, we will get negative 81.2. All right. And then for this 1 half, negative 9.8, multiplied by the square of 0.203, what we will get is negative 0.202. All right, so the two terms or the two numbers are both negative. So we simply add them. That gives us 81.4 meter. All right, displacement is downward or below the top of the cliff, which is our reference. All right. So we consider the displacement below the top of the cliff to be negative, equals 81.4 meters. But since what we are looking for is scalar quantity, the height of the cliff, we just remove the minus sign and conclude that the height of the cliff is therefore equal to 81 meters. So that's about all. Okay. I hope you understood how the concept of what do you call this? How we apply the concept of kinematics, okay, the formula for kinematics in analyzing uh, projectile motion. Okay, don't forget to subscribe to my channel. Thank you very much.